Okay, so this is 6.4, proportional and non-proportional relationships. Here's our key concepts. Take a moment to get these into your notes, and then when you're ready, I'll explain them. Proportional means two quantities have a constant ratio, and constant means the same thing. Non-proportional are rates or ratios that are not constant. That means that they're not going to be the same. Not constant. And then a constant of proportionality can be described by using the equation of the form y equals kx, where k is going to be that constant ratio. So we want to look at this k as what we're going to be dealing with. Your y's can change and your x's can change. Those are going to be seen as variables. And I'll show you what I mean by that, but you can think of it kind of like a function, input and output. And your k is always going to remain constant. Okay, that's why k is the constant ratio. Okay, so the first example is determine whether the set of numbers in each table is proportional. Well, remember what proportional means is that it's going to be a constant rate. So first of all, what we need to do is we need to write each of these as a rate or a ratio. So 1/3, 2/6, 3/9, and 4/12. And now I need to simplify these. So 1/3 simplifies to 1/3, 2/6 is 1/3, 3/9 is 1/3, and 4/12 reduced to 1/3 as well. Now looking at this, I see that each rate is simplified to be 1/3, 1/3, 1/3, 1/3. So because this is a constant rate, the rate is the exact same, this is proportional. Yes, this is proportional because the rate is 1/3. All right, you try this one. All right, so we get 1/8, 2/16, 3/24, 4/32. So this reduces to 1/8, 1/8, 1/8, 1/8. So is this proportional? Yes, because it is a constant rate of 1/8. Don't forget you have to explain. Okay, here's another one. I'll do this one. We are going to write 1/50, 2/70, 3/90, and 4/110. So 1/50 is 1/50. 2/70 is 1/35. 3/90 is 1/30. And 4/110 is 2/55. Okay, so now we're looking at our rates. 1/35, 1/30, and 2/55. Now, are these all the same? No, they're not all the same, so this is not a proportion. Not proportional. They have to be the exact same in order for it to be proportional. Try this one. So this is you do 1/6, 2/14, 3/22, and 4/30. Okay, so this rate is 1/6. This is 1/7. This is actually still the same at 3/22. And 4/30 is 2/15. Okay, now looking at these rates, are these the exact same over and over and over again? Is it constant? No. All right, now here is a word problem. Okay, this is going to be dealing with constant of proportionality. Okay, so it says a circle's circumference is proportional to its diameter. Circumference is proportional to its diameter. Now, those are some fancy words. Circumference means the perimeter of a circle, and the diameter means that line that splits it right in half, all the way from one side to the other side going through the center. So that's what that means. Circumference is proportional to its diameter. The circle shown has a circumference of 12.56 meters. Write an equation relating the circumference of the circle to its diameter. What would be the circumference of a circle with a 6-inch diameter? Okay, so this is part 2 of the question. So we'll tackle that in a minute. So let's look at this one. Write an equation relating the circumference of the circle to its diameter. We're going to do that first. So first of all, I have to find the constant of proportionality. Well, in order to do that, I'm going to set up the circumference to the diameter, right? Circumference is proportional to the diameter, right from the problem. And the problem tells me that 12.56 is the circumference, that's why it goes on top, over the diameter. Well, here from the problem, we see our diameter is 4. Divide that in your calculator, you get 3.14. Okay, so now we're going to set up our equation, knowing our constant of proportionality. So it says the circumference is about 3.14 times the diameter. So you could set it up, C is the circumference and D is the diameter. So C is going to equal 3.14D. Remember at the beginning of the slide when I said y equals kx? Well, what they've done is they've just replaced the y with a capital C for circumference and the x with the D for diameter, and here is my constant of proportionality. That's my K. Okay, so now part 2 of the question asks, what would be the circumference of a circle with a 6-inch diameter? So because I have this equation, C equals, well, I kind of wrote it all over it. C equals 3.14D, and I want to know what it's at with a 6-inch diameter. I'm going to say C equals 3.14D. Replace D with 6, multiply it out in your calculator, you get 18.84. So your circumference is about 18.84 inches. All right, you try this one. Find your constant of proportionality and then answer the second part of the problem. Okay, so we want to find the constant of proportionality for 2.5 pounds. That is $7.20. So how do I write that? Well, that's going to be $7.20 for 2.5 pounds, which is going to be equal to $2.88 per pound. So all I did was I divided 7.2 or $7.20 divided by 2.5 to get 2.88. And so my constant of proportionality is going to compare. I'm going to compare the cost to the pounds. Okay, so the cost to the pounds. And my constant of proportionality is 2.88. Now, I can find the cost of 4 pounds by plugging in 2.88 times 4. And the cost for 4 pounds is going to be $11.52. All right, here's our homework 29, page 287, 4 through 11. Try the best you can. We'll talk about these on Monday.